Hey guys, this is the video I promised to upload to show you how to take care of the Geogebra portion of the project. So here is your project 2 instructions. The link to Geogebra is on that document there. So if you just click project 2 and then click the link, it'll take you to Geogebra Classic and you should have this screen. To get rid of this guy, just click there. Okay. So here's what we want to do. So once you have found the object that with circular cross sections, your creative object that you've chosen, you need to take a photo of it or upload the image from online. So what I've done is I have chosen this Ming vase here to do the example with. Okay, so to upload that from the directions, you can see you're going to hit this little A=2 deal here. This is going to allow you to insert an object. So click on that and then click image and browse. Then select the file that you want. You may have to navigate to where you've saved it. Here it's in my pictures folder. So I'm going to put in the Ming vase. Okay. So it's going to give you 2 points which you can manipulate with your photo there. Okay. So in the directions, I asked you to scale the photo to the proper dimensions of the actual object. So you may have to do some measuring, or if you've picked a particular image from online, you may have to do a little bit of research about the dimensions of your object. So I've done some here, and what I want to do is position this so that it's symmetric along the x-axis. So the top half of this is what we're going to revolve around the x-axis. So I want to scale it to be the appropriate size of the object. I have researched this particular Ming vase, and it is about 40 centimeters tall. So I'm going to zoom out until I get to my scale, and then just scale the object equally in both directions until we get to about 40 centimeters, keeping A and B equidistant from the origin. So maybe go a little bit more. Okay, so that's about the dimensions of the Ming vase, right? Now, what we're going to have to do is position this guy so that the starting point is on the origin, right? So our lowest bound on our first integral is going to be at 0. So to do that, it's kind of hard to see with the picture in the way where the origin's at. So to do that, just slide it over a little bit and plot a point. So if you go up here, we're going to plot a point right on the origin. Okay, and make sure that it is the origin there. Then don't click anywhere else. You'll put another point there. Go back to your cursor, and now you can move it so that the very bottom of your figure is on point C. Okay. Now what we want to do is fix this image into the background. So to do that, we're going to go to Settings, which is a little gear there, and we're going to select background image. Okay. So you can see here that the image has been thrown into the background, and now you cannot move the image around. If it's not to where you want it to be, just go back to your settings, unclick background image, and then it's going to be movable again. Okay. At this point, you may want to change the rounding as well. If you go to the little gear here, click that, and then let's move the rounding to 4 decimals. And click out. All right. So now what we want to do is fit some curves to the various parts of this vase, right? So it looks like I'm going to have to do it in one curve here to get this portion of it. another curve maybe to get the middle of the vase, and then one to get the top of the vase, the vase here. So let's look. How do we do that? Well, what we want to do is basically we're doing some regression here. Geogebra will do that for you. What we're going to do is just plot a whole bunch of points along the border of the top half of your vase, right? So let's do that. Put some points. So C, let's put one there, put one there, along the edge. It's also important, it works the best if you include maximums and minimums of the piece that you're on. So there would be a maximum of it, and then maybe one. We zoom in a little bit. Right where the one piece transitions to the other, maybe right about there. Okay. So C, D, E, F, and G are going to be the points that are on the bottom portion of the vase. Then I'll do some more points here. Kind of move this. Plot some more points along the middle section of the vase, on the edge. Okay. You don't need to do a million points. Just kind of space them out like this, getting your max and mins there. Again, if you want to move, make sure you click on the cursor tool so that you can drag it. Otherwise, you'll be plotting points everywhere. It's kind of annoying. Okay. And if your point is kind of off a little bit, you can always move them around, right? You can just click on the cursor tool and then place it if you're off a little bit. Okay. Let's zoom back out. Now the directions ask you to create lists for each piece here. So I'm going to break this up into 3 curves. One for the bottom of the vase, one for the middle of the vase, and then one for the top of the vase. Here's how we're going to do that. I'm going to call the first list bottom vase. It's a good idea to keep track of what curve is what, or what list is what, by naming it something applicable to what you want it to be. Then curly brackets, and then I'm going to put in the list for all the points that are on the bottom of the vase. That's going to be C, D, E, F, and G. And just hit enter. Do the same thing for the middle of the vase. Curly brackets, and then list those points. I'm starting it at G, H, I, J, K, L, M, and then N. Let's stop it there. You don't want to do too much because you may not be able to get a curve that is going to fit the entire length of this thing. So it's a good idea to break it up into some pieces. So hit enter there, and then the top of the vase equals, we'll start from N and go to S. Right. Now that we have our lists, we can start to fit polygons to, or excuse me, polynomials to the curves here. So the outside, the very upper edge, we're going to try to fit some curves to it. And what's nice about Geogebra is it'll give you the equations of those things. Okay, so if you start typing in the input bar down here, start typing fit, and it's going to give you a list of a bunch of stuff, right? So what we want to do, depending on what you want to fit, you can fit exponential equations, you can fit lines, you can fit log functions, logistic functions, or polynomial functions, a bunch of different stuff. So polynomials will probably work best for you. So just click on that. Well, what happened there? That's not good. Hang tight. Delete that. Try this again. Fit poly. And that's the one we want. So let's hit enter. All right. So when I hit enter, it gave me the proper thing. So now you can notice that it wants the list of points that we're trying to do. That's why we made our lists here. So let's type bottom vase. That's the list of points. If you hit the directional key over to the right, it'll highlight the degree of the polynomial here. So this wants the degree of your polynomial. So what do we think is going to be good for getting this kind of portion of the curve? Well, we might be able to get it from a quadratic, like a parabola there. So let's see what that gives us. Okay. So you can see that parabola fits it pretty well on the bottom part of it, right? If we zoom in there, but not so well up here. So how are we going to do that? Well, we could do one thing. So notice that we can still move these points. And now as we move the points, it also moves the curve and it changes the equation over there to the left, right? So what we want to do is try to get, we can move these points out of the way, try to get the best fitting parabola to it. Or instead, we could change the degree and see if that helps out. So we change the degree to a third degree polynomial. That might actually be a better fit there, right? If we kind of play around with f there, that looks good to me, okay? So here it is. Here's our equation. It's 1.3375 x to the third. If you didn't do the decimal, increase the decimal points there, it's going to be a little less accurate when you get to subsequent parts of the project. So I would recommend that you do that. Okay. Now if we zoom out, so that looks good to me. Now we're going to go for the middle section of the vase, right? We're going to try to fit another curve to the middle part of this. So we're going to do the same thing, fit poly. Again, that's not great. Not sure why it's doing that. Let's go fit poly. Just hit enter instead of clicking on it. I'm not sure why it's doing that. List the points. So now we're dealing with the middle vase points, right? So middle vase. Hit over and then do your degree. So let's try. Looks like a parabola. It's not really symmetric there, right? It's not really symmetric along the middle. So let's try a higher degree. Let's try a 3 and see what happens. It's not bad, but you can see in a couple of spots it doesn't really, like it kind of overshoots K there. So if I pull K down, it kind of undershoots L and M now, right? So let's move K back to where he was. Try a higher degree. Okay, make this a degree 4 polynomial. And enter. All right, so you can see the higher degree got us kind of where we want to be. So it fits it real nice, not too much undershot or overshot there. So that looks good to me. If you didn't change the decimals, this would tell you it was 0 because it's such a small coefficient. All right, let's do the last one. So fit poly. In there. Our list is top vase. And let's try, my parabola might work there. Let's try degree 2. Not quite, that's kind of off. Let's try degree 3. It's a little better. Let's try degree 4. That's really nice, right? That's really nice there. So that looks like it's a good one. I think I have an error here. Oh, I've included M. Let's change that. Okay. All right, so that's better. All right, so you can see that that fourth degree polynomial fit it almost perfectly, which is nice. Okay. So that's how you fit curves to your figure. Note that we only need the top edge, right? Only need the top edge because we're going to revolve this thing around the axis. Now I also didn't put like a vertical line here because this point is going to create that edge that we're looking for at the top. So no need to put in any vertical lines there. All right, so that does it for this tutorial of GeoGebra. Now, make sure that you are saving your work as you go, okay? So if you go up here to the 3 lines, hit save, you may get a window that pops up that asks you to do some like put in an email or anything. You don't need to do that. Just exit out of that if you see that, and you should get this guy here, okay? So let's save it as, project 2, save, and save file. All right. Now, note that that's going to go into your download folder. So in order to access it again, it's going to be in downloads right there. Okay, if you're on a PC. If you're on a Mac, it should be there too, in wherever your download file is. All right, so that should do it. If you have any questions, feel free to email me, set up a time for office hours, or ask me before or after class. Okay.